So we started with kinematics. कौन student थे जिनको नहीं clear था? Please, can you speak out?
It's me, Akash Kalra.
Akash. So Akash, what is the basic difference between statics and kinematics?
In statics, we consider forces in the equilibrium. In statics, sir, yes, we consider bodies to be in equilibrium. We consider forces acting on them.
Okay.
And in kinematics, we consider velocity, acceleration,
okay, velocity
and displacement.
Then what about dynamics?
So in that we consider force and acceleration and momentum.
Force, acceleration and momentum. So now I am starting, I will give a brief overview because again then we will be falling short of time otherwise if I keep on repeating everything. So in statics, जो आपने अभी तक पढ़ा था, we were interested in the fluid that was essentially at rest. But the analysis also pertains to fluid that is moving with some constant velocity. वो हमने cover नहीं किए. So, but the rules remain the same. So you can treat the moving fluid. For instance, if this is a glass of water and you are moving this with some velocity v, then what will happen is you can treat this part of liquid in static equilibrium under the action of all forces. So the analysis remains the same because there is zero acceleration. So again here the same thing will apply, that is sum of all forces in x, y and z direction, they should equate to 0. So that was all about statics. Then in dynamics we deal with accelerating fluids, and acceleration does not mean rigid body acceleration, it means the fluid element itself is deforming also, it may be rotating also. So this is what dynamics involve, and dynamics involve why the fluid is behaving in this fashion. So what is the force behind this fluid element that is making it to rotate or to deform? So that is called the dynamics part. And kinematics part is only looking at the geometry. तो हम सिर्फ किस पे ध्यान दे रहे हैं कि what is the change in geometry. For instance, अगर मैं बताऊं आपको, say this is a channel, and if I say there is a fluid element just here and there is a fluid element just here. So what do you think? What will be the difference between these two elements, 1 and 2, when they are moving? What will happen? This is the surface. So how 1 and 2 are different? How 1 and 2 are different? I'm making it much more simpler now. Say this is 1 now. What is the difference between the movement of fluid element 1 and fluid element 2? क्या फर्क होगा दोनों में?
Sir, trajectories का फर्क होगा?
नहीं, this is fluid element. This is fluid element. That is, fluid is flowing in this direction, and this is a stationary plate. तो अगर हम किसी
वेलोसिटीज का फर्क होगा, वेलोसिटीज का फर्क होगा.
हाँ, तो अगर ये फ्लूइड एलिमेंट बोलूं, फ्लूइड एलिमेंट कौन से फ्लूइड एलिमेंट में फ्लूइड एलिमेंट की शेप चेंज हो रही होगी?
सर फर्स्ट वाले की फर्स्ट सेकंड वाला रुक जाएगा और फर्स्ट वाला
नहीं, सेकंड वाला रुकेगा नहीं ना, ये वाला पार्ट डिफॉर्म होने लगेगा, ये वाला पार्ट
डिफॉर्म होगा. एग्जैक्टली
डिफॉर्म होगा ये वाला पार्ट. इसके नेक्स्ट वाला भी इससे थोड़ा कम डिफॉर्म होगा. And this is not at all deforming because it is very far from this stationary surface. तो अगर मैं सिर्फ इसकी डिफॉर्मेशन को देखूं कि कैसे डिफॉर्म हो रहा है, या मान लो रोटेट भी हो रहा होता, विदाउट रिगार्डिंग कि क्या उसको ऐसे कर रहा है, क्या उस पर फोर्स लग रही है, क्या स्ट्रेसेस लग रहे हैं, तो उस स्टडी को मैं बोलता हूं काइनेमैटिक्स. And in the previous lecture and this lecture, we will be interested in this kinematics part. That is, how is the fluid element moving within the flow, whether it is deforming, whether it is not deforming, whether it is rotating, whatever is happening to that particular fluid element, we are interested in that, but we are not at all bothered that why it is happening so. So please remember, dynamics and kinematics, they are interdependent. You cannot divorce the two. It is only that we are now interested only in the kinematics part without bothering what has led to that kinematics. Are you clear? Hai? And I gave you an example. So you will never say JEE mains result is out. Say for instance, you will be interested in what are the marks of various students. So you will not be interested in that what led this student to secure 97 out of 100, what led this 72 out of 100, and what led this student 36 out of 100. So you are only bothered about these numbers, but you are not bothered that what was the effort behind these. So if you were going to details of the efforts, for instance, this person was critically ill or was from a very modest background. He could not afford the textbooks, he could not afford the learning material. And there was another student who also got 36, but he was from a very rich family, but was not spending time on studies. So although 36 figure is same for both the students, the dynamics which led to this number is different. And you clear? Hai? So you are only interested in the number. If you are only interested in the number, then it is called kinematics. But if you are interested why this number has come, that is called dynamics. And you clear? Hai? किसी को कोई भी doubt? Any doubts to anyone? And how are these connected? I gave you an example. Which one is the kinematic part, which is the dynamic part? Dynamics is cause and kinematics is the effect. So in this equation, what is the cause? What is the cause?
Acceleration, force.
Force is the cause. So this is the dynamics part. What is the effect? Acceleration. So this is the effect. And these two are related together with a material property that is called M here. That is the mass. So please remember, dynamics depends on kinematics, or kinematics depend on dynamics through a material property, and the entire thing is called constitutive relationship. Any clear? Hai? Any doubts? Any doubts to anyone? And one thing more, like I gave you the previous example, if you have a ball, you drop it, it follows this trajectory. If there's a ball, you throw it in horizontal direction, it follows this trajectory. So in both cases, on the ball, as it is moving, force is mg only. There is no other force. If you neglect drag, But in both the cases, you see a different trajectory. That is, kinematics is different. Although dynamics is same. So where are we missing? There should be one more thing that is dictating the final kinematics. What is that then? Because dynamics is same in both the cases. That is, gravitational force is operational in both the cases. But we are getting different trajectories. What is the reason?
Direction of force being applied.
Direction of force. You haven't applied any force. So although say this was moving at this was at a constant velocity v in the horizontal direction. This was having 0 horizontal velocity. So it means initial and boundary conditions also dictate the final kinematics. अब इसकी एग्जांपल क्या हो सकती है? अभी इस क्लास में सभी लोग एक ही लेक्चर सुन रहे हैं. So that is dynamics part. That is the force, that is the lecture is same for everyone. Each one of you are perceiving the lecture in a different manner because you have a different state of mind as of now. So finally, whatever you gather or whatever you understand, in addition to my lecture, depends on what frame of mind you had at that point in time. So you can always draw an analogy between science and your behavior. So that is how kinematics and dynamics are related to each other and always related to each other through a material property. और आपको ये भी आपको याद होगा, I am again say, now I think you will be much more, say tau is equal to mu du by dy. You remember this?
Yes, sir. Yes.
What is this? Shear stress in a Newtonian fluid is equal to rate of shear strain, and this was the proportionality constant. So what is dynamics part here?
Shear stress.
Shear stress is the dynamics part. What is the kinematics part?
du by dy.
du by dy.
This is the kinematics part. And what is the material property that is building a relationship between the two?
Mu.
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 So this is the material
Coefficient.
property. So this entire thing was called Newton's law of viscosity, and that is also called a constitutive relationship. And clear hai? Any doubts to anyone? And
No.
one last example for kinematics is, if you have, say for instance, एक आपके पास बार है, आपने इस पे कुछ हीट फ्लक्स अप्लाई कर दी, and I am giving the equation as like this, minus k dt by dx. तो इसमें काइनेमेटिक्स पार्ट कौन सा, डायनामिक्स पार्ट कौन सा है?
Kinematics.
Heat conduction is the phenomena. So what is the kinematics part and what is the dynamics part?
Sir, heat conduction kinematics.
Heat conduction means,
So
what
Q,
is this?
Q.
U is dynamic.
This is dynamic. Because of this only the temperature is changing in x direction. So this is dynamics part. This is
Dynamic.
kinematics part. And what is this?
Material.
The material property.
Material property.
Any clear? Any doubts to anyone? Now a little bit of a philosophical thing. If you understand this, then let me know. Say this was at 100 degrees Celsius, this was at 10 degrees Celsius, and this was, say, length 1 meter. Now if I ask you q double dot double dash is equal to minus k dt by dx, तो आपने क्या किया, एक को गरम स्टीम के पास रख दिया, एक को कहीं लो टेम्परेचर पे रख दिया, बार को, एक एंड को. Now let me know what is the statics part, what is the kinematics part, and what is the dynamics part. What is the cause and what is the effect? What is the cause now and what is the effect? पहले केस में आपने फ्लक्स अप्लाई की थी, इस केस में आपने दो एंड्स को डिफरेंट टेम्परेचर पे रखा हुआ है. तो डिफरेंट टेम्परेचर पे रखने की वजह से क्या होगा इस बार के
हीट जनरेट, सो हीट
फ्लो करेगी वाटर से कूलर प्लेस पे.
Heat will flow from high temperature to low temperature. So in this case, what is the cause? This thing?
Temperature difference.
The temperature difference.
So dt by dx is the cause. And clear?
Yes,
Hai?
Yes, sir.
What is the effect?
Flow.
This movement of heat. So this is the material property. So I should have written this in this format as well. dt by dx is equal to minus 1 by k q dot double dash. So this is the dynamics part, this is the kinematics part, and this can be treated as the material property. And clear है? किसी को कोई भी doubt? Any doubts in kinematics, dynamics, and the relationship between the two? कोई भी doubt? Should I move forward?
Yes, sir.
So kinematics involves actually what you see, and in fluid, whatever you see is either the fluid element is deforming. It can deform like this. It could deform like this. It could deform like this. So this is the fluid element. So this is what can happen to the fluid element. What else can happen to the fluid element? It may have rotated. So that means it has rotated with some angle. So this is the angular deformation. This is linear deformation in x direction. This is linear deformation in y direction. And this is rotation. So this is what can happen to an individual fluid element. And what else? This is one thing, one kind of kinematics, that is you are actually seeing what is happening to the fluid element. Now this fluid element itself may be moving with some velocity. So you can define the velocity, the displacement and the acceleration of this fluid element. तो अगर आप इन सब चीजों को आप डिफाइन करना चाहते हैं या ऑब्जर्व करना चाहते हैं, that is called kinematics. And while describing everything like this, you are not at all bothered that why it is happening so. And that's why this is entirely, in a way, not connected to dynamics, because it is also connected to dynamics, but we are not bothered that what has led to this kind of motion or deformation or rotation. So if the study involves only what is happening, but we are not essentially interested why it is happening, then it is called kinematics. Any clear? Now, in case of fluid element, because fluid element, सबसे पहली प्रॉब्लम क्या है? अगर ये एक मान लीजिए रिवर है, क्या आप फ्लूइड एलिमेंट को आइडेंटिफाई कर सकते हैं? यहां पे पानी फ्लो कर रहा है, क्या आप फ्लूइड कोई एलिमेंट चुन सकते हैं कहीं से?
No, sir.
Because you cannot actually distinguish any particular fluid element. कैसे कर सकते हो? अगर यहाँ पे आप कुछ डाई फेंक दो तो वो डाई उस लिक्विड को कलर कर देगी और उसकी मूवमेंट को आप ट्रैक कर सकते हो फिर. So that is a fluid element in that case. So please remember, in solids you don't have this problem, and that's why अगर ये बॉल थी कोई, आप बॉल की लोकेशन, उसकी वेलोसिटी, उसकी डिस्प्लेसमेंट, उसकी एक्सेलरेशन ट्रेस कर सकते हो. अगर 3-4 बॉल्स भी थी आप उनकी भी कर सकते हो, बिकॉज दिस इज फाइनाइट नंबर ऑफ बॉडीज. But in this case, you don't have finite number of bodies, and the body itself is deforming, rotating, and it is doing a lot of stuff that you cannot actually understand. So if you track solid individually, or you track a fluid element as it moves in the flow, that is called the Lagrangian approach. इस अप्रोच को आप बोलते हो लैग्रांजियन अप्रोच, कि आप फ्लूइड एलिमेंट को ट्रैक कर रहे हो एज इट इज मूविंग इन अ फ्लो फील्ड. सो दैट अप्रोच इज कॉल्ड लैग्रांजियन अप्रोच. बट दिस इज नॉट एडवाइजेबल बिकॉज इट इन्वॉल्व्स अ लॉट ऑफ कंप्यूटेशनल एफर्ट, क्योंकि आपको ये नहीं पता कितने आपको एलिमेंट्स हैं आपके पास, यू डोंट नो. So in a flow field, you can have, somebody can choose this as fluid element, somebody can choose this as fluid element, and you need to track the interaction between these two fluid and between these fluid elements. So it is very difficult to track these particles. So that is the disadvantage of Lagrangian approach in fluid mechanics. Are you clear? Any doubts? So this is what is defining the Lagrangian approach in case of solids. I think you might have seen this. So you are tracking the particle or the ball wherever they are moving. So that is the Lagrangian approach. But opposed to this, you have Eulerian approach. Eulerian approach means you are not bothered what is happening to the individual particle. You only take, say this is the flow happening. You take this region of the river and you analyze whatever is passing through this region. So you are not bothered how did the various particles reach this region. You are only bothered that when they reach this region, what is their velocity? And when they exit this region, what is their velocity? So you are only tracking a change that is happening from A dash to BB dash. You are not at all bothered कि कहां से ये आ रहे थे और ये कहां को जा रहे हैं. You are not at all bothered. You are only visualizing or analyzing what is the velocity, displacement, acceleration field as it crosses this particular region. And that is called the Eulerian approach. And I think most of you might have encountered this approach. If you have ever met with a policeman, so police kahan pe hai? Police post is just like this only. On the road, the police does not track each and every vehicle. What police does is, it selects a post and it stops every vehicle that crosses by. So that is called the Eulerian approach. अगर हर एक vehicle के पीछे हम एक policeman लगा दें, that is called the Lagrangian approach. So which is practical in this case? And what do you see in your daily life?
Eulerian approach.
Eulerian approach is practical. But For instance, I give another example where Lagrangian approach is practical. I gave this example the other day also. Say this was a chimney that was emitting some smoke. You want to analyze that what is the flow pattern of this smoke, where does it go and which areas it impact the most. तो आप क्या करेंगे? You will actually track the movement of the smoke, and that is called then Lagrangian approach. So Lagrangian approach is useful in pollution studies. Wherever we want to track that how does the pollutant particles move, then we will have to do the Lagrangian approach. हाँ जी, क्लियर है? किसी को कोई भी डाउट? नाउ Lagrangian approach की बेनिफिट और क्या हो सकता है? What is the benefit? Quickly let me know. So these were the balls, and this person applied some force on this ball. So the movement of this ball will be dictated by which principle?
The direction of force applied by the person.
So I can write down this as force equal to mass into acceleration.
Yes, sir.
So, and this is Lagrangian approach. So please remember, all physical laws have been originally or inherently developed for Lagrangian approach. जैसे इसका मुझे मोमेंटम कंजर्व करना है या इसकी काइनेटिक एनर्जी करनी है half mv square. So what I am concentrating on, this mass of ball, that is the control mass. So I am tracking the ball and finding out its energy as it is moving. If it collides with the other ball, there will be momentum exchange and its kinetic energy will change. And all the laws which you have studied in high school physics are inherently like this. So they are applicable on a given mass. लेकिन Eulerian approach में क्या होता है? हम एक region of space को एनालाइज कर रहे हैं. तो अब मुझे बात बताइए, यहां से बॉल जा रही है, इस रीजन से ये निकल रही है. आप इसकी बॉल की तो एक्सेलरेशन पता लगा सकते हैं, इस पे फोर्स पता लगा सकते हैं. इसकी एक्सेलरेशन मेजर कर लीजिए कि यहां पे इसकी वेलोसिटी v1 थी, यहां पे वेलोसिटी v2 थी, और यहां पे टाइम t1 था, यहां पे टाइम t2 था. तो एक्सेलरेशन कितनी होगी?
v2 minus
v1 अपॉन t2 minus t1. तो आपने पार्टिकल की एक्सेलरेशन तो डिफाइन कर दी. इफ आई आस्क यू what is the acceleration of this region in space and how did it accelerate in this region of space? So it will be difficult because laws are not defined for regions of space. Laws are defined for mass of a body, particle, and all that stuff. So all the laws, they have inherently been of Lagrangian format. तो Lagrangian से Eulerian में जाने के लिए आपको लॉ या आपको थ्योरम्स लगानी पड़ती हैं, and I think one of the students has already pointed out, and those are called Reynolds transport theorem. So that means if you want to convert a law from Lagrangian approach to Eulerian approach, this Reynolds transport theorem will help you to go from Lagrangian to Eulerian or back to Lagrangian. So this Reynolds transport theorem is just a vehicle that takes you from Lagrangian to Eulerian and from Eulerian back to Lagrangian. So that is one of the disadvantage of Eulerian approach, because you don't have laws that are originally defined for Eulerian approach. लेकिन आपके पास ये थ्योरम है, इसलिए जो भी लॉज हैं आपके पास, आप उनको Eulerian approach में कन्वर्ट कर सकते हो इस थ्योरम को लगा के. That is Reynolds transport theorem. Any clear है? Any doubts to anyone? किसी को कोई भी डाउट? Please ask me if you have any doubts. Akash? Akash?
No doubt, sir. No doubt, sir.
Okay. So now I am coming to, so I told you Eulerian approach is much better. So we will be from now onwards always talking about Eulerian approach. So please remember, ज्यादातर हम Eulerian approach में ही डील करेंगे in fluid mechanics, because this is much simple to apply. So please remember, in Eulerian approach we are defining a field. अब फील्ड का क्या मतलब है ये ध्यान से देखिए. अब यहां पे कोई फ्लूइड फ्लो कर रहा है. So fluid is flowing in this river. So what is, if I say, what is the velocity field? Velocity field. Velocity field क्या होगी? What do you mean by velocity field?
V vector in x, y, z and t.
So if you can define at every point what is the velocity, that is the velocity field in this region. Any clear है? This is called velocity field. तो अगर मान लीजिए कोई फ्लो हो रहा है और वहां पे हर पार्टिकल की कोई वेलोसिटी है, you click a photograph, that photograph is giving you the velocities, accelerations of each and every point you choose in this region. So that is the field. जैसे कि और एग्जांपल है, जैसे मैंने पहले बताया था, आपके पास एक मैग्नेट है, नॉर्थ टू साउथ है, तो व्हाट डज, हाउ डू यू सी मैग्नेटिक फील्ड लाइंस? It goes something like this. If you remember these are magnetic field lines.
Yes, sir.
Yes, sir.
So if I ask you what is the field around this magnet, क्या वो कांस्टेंट होगी मैग्नेटिक फील्ड की, वेरिएबल होगी? यहां पे डिफरेंट होगी वैल्यू बी की, यहां पे डिफरेंट होगी वैल्यू.
सर वेरिएबल.
ठीक है. तो अगर मैं बोलूं फील्ड इस रीजन में क्या है, तो व्हाट विल यू सी? आप हर एक पॉइंट लेंगे, उस पे बी की वैल्यू डिफाइन कर देंगे, एंड दैट गिव्स यू द फील्ड ऑफ मैग्नेटिक फील्ड अराउंड दिस मैग्नेट. सो दैट इज द फील्ड. हाँ जी, क्लियर है?
Yes, sir.
Now this is what is Eulerian approach, that you are defining everything at a single moment. Now try to see, this was a magnet, so this was a particle that was moving, so this was the magnetic field. Now you are analyzing, you are not analyzing that यहां पे आपको पता नहीं कि हर पॉइंट पे क्या फील्ड है, आप उसको पता लगाना चाह रहे हो लैग्रांजियन अप्रोच से. तो क्या होगा बेसिकली, अगर ये कोई पार्टिकल है, ये मूव कर रहा है, तो जब ये इसके पास आएगा, ये पार्टिकल यहां हुआ, तो इसकी मैग्नेटिक फील्ड इस पे जो लग रही होगी वो डिफरेंट होगी. जब ये पार्टिकल यहां पहुंचा, इस पे मैग्नेटिक फील्ड जो लग रही होगी वो डिफरेंट होगी. यहां पहुंचा, इस पे डिफरेंट होगी. यहां पहुंचा, डिफरेंट होगी. फिर यहां पहुंचा जब, उस पे मैग्नेटिक फील्ड डिफरेंट होगी. तो इफ आई मार्क दिस लोकेशन एज A, B, C, D, E, F, and this was a particle that was moving along this path, and these are the locations at which I want to find out the magnetic field on this particle. So this is the Lagrangian approach. That is, I'm tracking the particle and finding out what is the field at a particular location of that particular particle. हाँ जी, clear है? हाँ जी, कोई doubt? One more example. So this is a nozzle. Fluid is flowing in this nozzle. I insert a small particle here. Say its velocity is v1 here. As it moves, I'm tracking this particle. As it comes to, say, point B, and then C, then D, then E, what will happen to the velocity of point of this particle as it comes to A, B, C, D, E? क्या होगा? Will it observe some change in velocity or not? मान लीजिए आप ही यहाँ पे, ये पार्टिकल आप ही हैं, so you are moving in this channel of water. क्या आपकी वेलोसिटी चेंज होगी ए से बी के बीच में?
No, sir.
No, sir.
From B to E, from B to D,
Yes, sir.
आपकी वेलोसिटी चेंज होगी?
Yes, sir.
Yes, sir. होनी चाहिए.
So you are as such accelerating according to you. So this is the Lagrangian frame of reference. That is, we are tracking a particle. और अगर मैं बाहर भी खड़ा हूं, मुझे क्या लगेगा? ये पार्टिकल एक्सेलरेट कर रहा है. हाँ जी, क्लियर है?
Yes.
Now I'm coming to the other part. Say I have the same tube. I define velocities at each and every point. Now let me know, is the velocity changing with time? या मैं इसको ऐसे बोलूं, is this steady flow? Steady flow का मतलब क्या होता है? What do you mean by steady flow?
Velocity is constant.
Velocity is constant with respect to what?
With respect to the
position.
Time. So please
Time.
please remember, कोई चीज steady है इसका मतलब क्या होगा? उसका partial derivative with respect to time क्या होगा हमेशा?
zero.
अब मुझे बात बताइए, मान लीजिए ये फ्लो हो रहा है इसके अंदर, हर पॉइंट पे मैंने वेलोसिटी डिफाइन कर दी. इज दिस स्टेडी फ्लो और नॉट?
Yes, sir. Steady flow.
Steady flow.
Steady flow. Now if I look at this flow from a Lagrangian perspective, is this a steady flow?
No, sir.
No, sir.
क्योंकि आप खुद या जो फ्रेम ऑफ रेफरेंस है वो किसको कंसंट्रेट कर रहा है? पार्टिकल को. सो पार्टिकल विद टाइम इज चेंजिंग इट्स velocity. So please remember this subtle concept. So this is a steady flow from Eulerian frame of reference, and this is an unsteady flow from Lagrangian frame of reference.
So that means in Eulerian approach, we'll always have information about each and every point in the particular volume that we have taken.
So you are exactly correct. So that is what we have in a flow field also. एक फील्ड जब डिफाइन करते हैं तो हमें पता होता है कि हर पॉइंट पे क्या वैल्यू है उस वेरिएबल की. Now let me know from Eulerian description, how can this flow become unsteady?
Sir, if it is a turbulent flow.
नहीं, अगर यहाँ पे वॉल्व होता मेरे पास and say this was the flow field at time t, and say Ayush came and he suddenly closed this valve a little bit, what will happen to the flow feed? It will change.
Yes, sir.
So what has happened? So in Eulerian description also now it has become unsteady. हाँ जी, clear है?
अब अगर हम एक ही इंस्टेंट पे बात करते हैं ना, so if we are talking about time t, then it would be at a very time t, just it started, my t tending to 0, t plus, at that time the valve has been closed.
Okay, so you are not understanding the point. I am saying, for instance, ये इसका मतलब क्या हो? This is the definition of steady flow from Eulerian perspective. ये clear है?
Yes, sir.
So what does that mean? Say, I give you an example here. Say this is the example. Say this thing. Say at time t, this was the fluid flow. Somebody suddenly closed it or opened it more. So time t पे तो इसमें कुछ field थी, हर point पे velocity defined थी.
Yes, sir.
ठीक है, तो मान लीजिए v को मैं डिफाइन कर रहा था, कोई भी फंक्शन मान लो ऐसे होता है, एग्जांपल मैं बोल रहा हूं सिर्फ, से x² y, ठीक है. अब ये था एट टाइम t, और t प्लस डेल्टा t टाइम जब आपने थोड़ा सा क्लोज कर दिया, ये कुछ ऐसे हो गया.
Yes, sir. आगे.
क्लियर है? तो विद रिस्पेक्ट टू टाइम वेलोसिटी में चेंज आया कि नहीं?
Yes, sir.
So this is unsteady flow from an Eulerian description. And in most of the topics in the course, we are only interested in the Eulerian description of the flow. तो हम Lagrangian नहीं करेंगे. तो जब हम बोलेंगे कि ये steady flow है, अगर मैं ऐसे बोल दूं steady flow, it means by default I am talking with respect to the Eulerian description. So please remember this. तो अगर किसी भी पाइप में if I say this flow is steady, it means I am talking as per the Eulerian description. I am not talking as per the Lagrangian description. अगर Lagrangian से बात करूंगा तो I will specify that. So by default it means any kind of terms I use from this point forward applies to the Eulerian approach. So please be careful in that.